Hello everyone, this is Ahmed Higazi, and today inshallah we will discuss and discover the power of automation by using PSG software. Today inshallah we will discuss some points regarding the traditional way to get the support mark dimensions from the spec. In this one we will take a sample for support group named CR03. After that, we will discuss how to automate that by using PSG software for the same group and create different numbers or support marks from the same group. In the third part in this session, we will discuss how to generate an assembly for all of the group to calculate the total weight of the fabricated material from this group and calculate the total surface area if we would like to calculate that or use that number for the painting. In part number 4 in this session, we will discuss the drawing collection, how to collect all drawings for the support marks in one drawing with different sheets, each sheet for each support mark. In part 5 in this session, we will discuss how to generate a detailed bill of material for all of the group. In part number 6, how to calculate the raw material for all plates that we have, and that we will in this step we will discuss how to use the Autodesk Nest tool to calculate the required raw material for plates. Now let's start with part 1, which is the traditional way to get the dimensions of a certain group. Here in this group, which is CR03, as you can see, when you open this support group, it's related to spec. If you open this group, you will find two different sizes or two different shapes. The first shape suits sizes from 2 to 3 inches. Okay, and you can figure that this support not includes stiffening grips. And another size or another shape for sizes from 4 inches up to 24 inches. And you can figure that in that shape you have a stiffening grips. You have 4 stiffening grips at the bottom and another 4 stiffening grips at the top. And here, as you can see, you have stiffening grips here, 2 stiffening grips on that side and another 2 stiffening grips on the other side. Totally, you have 8 stiffening grips, 4 at the top side and 4 at the bottom side. Okay, and here you have a table to get the dimensions of T and W and A based on the size of the main diameter. And here below you have a bill of material, and this bill of material includes the material class, and we will discuss the material class on the next slides. Here, if we take a look to the support in deep, as you can see here, we have the support mark name. It includes some terms. The first term includes the group name, which is CR03, and the second name includes the diameter of the main line. Okay, so if you take a look here for the main size of the pipeline, this term indicates the size of the pipeline. And the second term from the support mark indicates the height of the bottom support, which is H1. Okay, it's measured from the outside diameter of the pipe to the end of the base plate. The third term, which is H2, indicates the height of the top support measured from the outside surface of the pipe to the end of the base plate. And the last or the previous last term, which is L term, which indicates the length of the base plate. Okay. Finally, the material class, and we will discuss this material class on the next slide. So from here, if you get the main pipe diameter, you will get the other dimensions for T1, W, and A. Okay, and as you can see here from this clip, which includes in this support mark, which is CE01. In the bill of material, this term, which is term number 4, indicates the clip of which includes in this support, which is CE01. That means we will need to go to another spec or another support group to get the dimensions of this clip. Okay, now let's move to the group CE01, which indicates the dimensions of this clip. Okay, now as you can see, this clip includes from 2 plates, and you have tightening bolts, nuts, and jam nuts. And here that table indicates the size of the main pipe diameter, and here on the row you will find the bolt length, bolt size, and the other dimensions for that plate, which is length, width, hole diameter, hole offset, and this plate thickness. And here below you will find a bill of material for this support group. Now, for example, let's give a name for a support mark. Let's say CR03-20. As mentioned, 20 means the main pipe diameter. That means the main diameter of that pipeline equals 20 inches. And here, dash 120, which means the height of the bottom support equals 120 measured from the outside surface of the pipe to the end of the base plate. The second term equals 200, which is defines the height of the top support measured from the outside diameter of the pipe up to the end of the base plate. And L, which is equal 500, which equals the length of this base plate, and finally the material class. Now, to get the dimensions of that support mark, we will need to go to the tables, which we mentioned on the previous slides. And from here, you can figure that the main diameter is 20 inches size. And for the height of the bottom one is 120, the top height 200, the length is 500. Dimension A from the table, which is the width of the whip, equals 200, and the width of the base plate from the table equals 450. And for the clip, dimension A, which is the width of the clamp plate, equals 70 millimeters, and dimension V, which is the length of this clamp, equals 934, and S, which is the thickness of this clamp, equals 10 millimeters for size 20 inches, and dimension M equals 35, Q equals 22, which is the hole diameter, and T, which is the spacing here between the top clamp and the bottom clamp, equals 20 millimeters, and the used bolt size equals 20 millimeter with length 90 millimeters. Now, to get the material for the elements, we will need to go to the table on the for the first group, which is CR03, and for the class, which is material class SH. Now we can get the material for each element, and here the base plate material should be a 516 with grade 60, and here the rib material and web material. For the clamp, the same thing, we will select SH material class and get the materials for each element. And from here you can figure easily how much it's difficult to get all of those dimensions from the spec, and to draw a single support mark, it means a lot of pain and consumed a lot of time to open the spec and get the dimensions from the spec, and by going to the tables, like that table, for example, for size 20, and get all dimensions here for this clamp, and the same for that support to go with that size and get the dimensions of T1, W, and A, and that you will do it for each support mark. Okay, now let's take this support mark, okay, and try to draw it by using SEG software, PSG software. Now let's open PSG, and from here, let's create a new project, and in this list you will find a list of items. Let's select CR03, which indicates this support, and if you would like to open the spec, just double click on this text and you will open the spec here. So if you would like to review something, you can do that easily. Here in that area, note number 4, you can figure that you have a slot hole, which is that hole on this web. This slot could be a single slot in case of the length equals 300 to 400. If it's from 500 to 700, you will have 2 slots. In case of you, the length equals from 800 to 900, you will have 3 slot holes. And all of that, you should take care about it during the modeling of or preparing the final drawing. Now let's create this group. Select the location of the group, and from create, let's select this group, and from here let's add the support mark, and let's make the quantity as 1 and painting system A1, for example. And now let's make a validation for that to check if this support mark name is identical or suits the spec or not. For example, if you have a size, let's say it's 30 inches. Okay, so if you click validate, automatically PSG will reject it because this size is not included on the spec. Okay, so if we come back to the spec again here, and for that spec, as mentioned here in this spec, you can figure that the sizes from 2 to 3, and for the second type from 4 to 24. So any size larger than that or smaller than that, it's not indicated on the spec. So PSG will reject it or refuse it. So now let's change it again to 20 inches and click validate. Now it's accepted. Now let's create the 3D model of this support mark and check how much time you will take to draw the 3D model and the fabrication drawings for the support. As you can see, in seconds, we generate the 3D model and fabrication drawings for this support mark. Now let's open the assembly. Here, let's come back to Disk Inventor. As you can see here, because the width of this base plate, or the length, the length equals 500, as per the spec, you will need 2 slots here. Automatically, PSG created with equal spacing. Okay, so we have this support suits 20 inches pipe size. Let's open the drawing. So from here, open the drawing. As you can see here, in that one, you have the height at the bottom 120, and the top height of the top base is 200, and here the diameter of the pipe, and here you have the bottom and the top stiffening whips, and here the clamp dimensions, which is 70 and 934 as mentioned on the spec, and here the stiffening ribs, and a detailed bill of material for this support mark for item 1, 2, 3 up to 9. So with a detailed material, so automatically the material changed based on your selection for the support mark and the material class, and here the quantity of supports required, and the weight of the support mark, and the total surface area for the support mark. So you can imagine how much time you will save in case of using PSG to generate the support mark. Now, it's not an issue if you have one support or 2 supports, but if you have a huge number of supports, how you can deal with that. Actually, if you will work with the traditional way, you will face a problem. To get a dimension for each support mark to generate it, it's a pain. Now let's reset this project and collect some supports by generate them by PSG. So let's clear this list and take that list, which includes a painting system and line and area. And from here, let's click on paste. Now we have this list for the support marks. Now let's make a validation to check that list. Actually, PSG detects that we have some typical items. So we have 21 typical support marks with total 107 support, the quantity of the supports. Now let's start generating, let's save this project first, and from here let's start generating the support marks by using PSG software. Now we complete the generation for all the support marks with all drawings, and from here we will go to the next step on the next part of this session. Now we will discuss the third part from this session, which is creating the total assembly for all of this group to calculate the total weight for the fabricated materials, and calculate the painting system surface area. So from here, from project, let's select a project, the assembly collector, and from the start button, we will click on start, and from here, PSG will start generating the total assembly for this project, which indicates the required number from each support mark. Okay, and that will give you the real indication for the weights and surface area for all of the group. Here finally the total assembly for the support mark is finished. Now let's calculate the total weight from the physical properties. Here as you can see it's equal 6 tons point 1. Okay, and here the surface area in millimeter to the power 2 here. That's the surface area for this one. Now let's go to the third part, which is collecting the drawings in one drawing. Let's close this, and from project, let's select drawing collection, and from start, let's collect all drawings in all sheets in one drawing. As you can see here, the number of sheets increased. Now we create all drawings. And here, as you can see, you have all sheets here for each support mark, and each sheet takes the name of the support mark. So easily you can go to your drawing easily and check the bill of material for this support mark, check the quantity weight and surface area. Pick the number of the sheet, the dimensions of each element, the height for top and bottom, and as mentioned, they should be in identical with the support marks values. Okay, hereby that way you can collect all drawings in one sheet. After that you can print in DWG or PDF or DXF, so you have different ways to export your drawing. Now let's go to part 5, which is calculating the detailed bill of material for the this support group. Now let's open a new drawing, and from here let's add a bill of material, and let's select the total assembly of the group and select parts only, and from here select support bill of material, and from here let's add this. Let's delete the border and title block. Okay, and now let's move this list right here, and now let's open this part list. Actually, you will find here a detailed bill of material for each element, and you will figure that you have 185 elements in this bill of material. Some of them are identical, like bolts, nuts, and some plates dimensions, so we can merge the identical items. So we will make an arrangement or make the merging based on the status, after that the material and the mass, and click OK. Now as you can see, the number reduced from 185 to 78 items only. Now you can make a sorting by the name, so let's sort by status, and from here, as you can see, we have the bolts and nuts at the top. After that, all blades will be here at the bottom. Now let's arrange the numbering, and here finally we have this bill of material. If we take a copy from this list like that and go to the our Excel sheet and put these values here, okay, and get the total weight for the elements like that, and now let's make the total weight for bare elements. Let's move down here, and now let's make a summation for the bolts and nuts. So as you can see here, the weight of the bolts and nuts in this group equals around 100 kilograms. And for the blades, let's make a summation for the blades here. So the total weight of the blades equals 6 tons, around 6 tons. Okay, now let's move to the next step, which is generating the nesting study for this project. Now let's go to the last part of this session, which is part number 6, which calculating the raw material required for plates by using Autodesk Nest tool, and how we will do that. Now we create the final assembly for the support group. From the assembly tab, let's select create nest, and after getting this form, let's select standard bill of material. And in this step, Autodesk Nest tool will collect the blades and all elements in this project and get the material and thickness for each blade and make a list of elements to start the nesting process. As you can see here, you have a list of elements, some of them for bolts and some of them for plates. After importing them, we will remove the bolts material and keep the plates material. As you can see here, we have a 240 group grade 304 with 10 millimeter thickness and the other plates here. Let's click on OK. Now the nesting tool will get the flat pattern for each element and to prepare it for the nesting study. We will wait some minutes until finishing this process. Now this step is done, and now it's time to start. As you can see, all items imported to the nesting tool. Now from the process material library, we will remove all the other materials for bolts and nuts. So like that, we will remove it. And keep all blades materials. Okay, now let's rename the materials. Now we keep all materials, material name and thickness appear here. So let's take a copy from that and change the ID of the material right here, like that. And if we have like that, and for this material, and finally this alloy material with 10 millimeters in thickness, and here we have a list of elements. Now let's accept this and start the nesting process. By the way, before going to the next step, here you have the package for each material, so you can define the length and width for the raw material that you have in your stock or workshop. So you can define that, and you can make some modifications regarding the item separation, frame width from the edges and the orientation of the blades. So we will keep the values as a default for the length 6 meters length and 1.5 meter width for each blade. Now let's start the creation of the nesting study. And from here, let's select the minimum length to arrange the blades on the short side as possible and keep the remaining length on the long side. So from here, select this option and click on OK. As you can see on the left hand side, the nesting process started for each blade category. So we will wait minutes to get the final nesting study for each blade. Now the nesting study is done. Let's click on save. And here we have the each nesting study for each material category, material and thickness. Here for the stainless steel material, as you can see, we will need this piece, and here we have the arrangement of blades in this sheet. For the stainless steel material with 10 millimeters thickness, we will need 2 sheets, so the total number of sheets required are 2. And here's the first sheet blades arrangement, and here you have the blade name and the required quantity between brackets here for each blade, and the name of the blade appear here on that one. And the second sheet will include those parts, and we will need around 620 millimeters only for the second part. For the carbon steel material with 10 millimeters thickness, as you can see, we will need totally 2 sheets, and the arrangement for the first sheet will be like that, and the parts appear here, and the quantity for each part between brackets appear here. and that's at the second sheet. We will need around 4 meters and 20 millimeters, 200 millimeters the length. And for the carbon steel material with 15 millimeters thickness, totally we will need 3 sheets, and the arrangement of plates will be like that. And for the carbon steel with 5 millimeters thickness, here we have that plate arrangement. And finally, for the alloy material, we will need 4 sheets, okay, and the arrangement of plates in each sheet can be arranged by that way. And you can export each sheet of those in DXF extension to send it to your workshop drawing to start CNC machining or the cutting process by using the cutting machines based on the DXF file. Now I think we cover all points in our session. So let's review that again. We discuss the traditional way to get the support mark dimensions from the spec and take a sample for CR03. And after getting this dimension manually, you will need to use AutoCAD or Autodesk Inventor or any other CAD software to generate your drawings based on the extracted dimension from the spec. And we discuss how to get those dimensions from the specs and how to understand the arrangement of that. On the second point, we discuss how to deal with PSG to generate a support mark by using for the support group CR03, and we generate a huge number of supports by using the same way. In part 3, we discuss how to generate the assembly for all of the group, including the required number for each support mark, and calculate the total weight of the group as a fabricated weight, and calculate the painting area or the surface area for all of the group. In step 4, we discuss how to collect all drawings in one drawing with different sheets. And in step 5, we discuss how to generate a detailed bill of material for the group and calculate the weight of bolts, for example, nuts, separate the nuts, or the separate weight for nuts and bolts, and the separate weight for plates. And if you have a pipes or hot rolled section, you can hot rolled sections, you can get the separate weight for them. And finally, we discuss how to make a nesting for plates and get the required raw material that you will need in your workshop, and how you can cut it to save the raw material. And finally, we discuss the 6 points, and I hope that session give you a good indication about the capabilities of PSG software and how it works. Thank you for your valuable time and have a nice day. Assalamu alaikum.